that the dumbest thing? I mean, the goal is to get through all the material. It is a lot of things. But, so we're going to skip a little bit of chapter 5. 10 and 11 are area and volume, so we'll be skipping through those a little bit since you guys know area and volume stuff. Alright, so chapter 5 is about more properties of triangles. Okay? We're not really going to do many proofs in this chapter. Okay? It's going to be more properties. So today, the first property that we're going to look at is the exterior angle inequality theorem. So if you remember, before we talked about the idea that an exterior angle is equal to the sum of the non-adjacent interior angles. Okay, so before we said here that this marker doesn't work. Thank you. We said the measure of angle 1 would be equal to the measure of angle A plus the measure of angle B in this situation. Right? The exterior angle is equal to the sum of the two non-adjacent interior angles. So, yeah, I mean, the example we gave was, if this angle was 100 degrees, well, we know for sure that that would make this one 80. So then these two would have to add to 100.
I believe we know everything about current.
Not yet. Just hold on to your pants. There's more to come.
I don't know.
Okay, so today then, we're just going to kind of take this idea one step further and say, well, if we know that this angle has to equal the sum of these two angles, well then this angle has to be larger than either of these angles individually. Crazy, right? It is kind of common sense, right? So, really, all we're doing on the front here, okay, is looking at certain statements and listing all the angles that fit that criteria for sure. Okay, so, for example, this one says list all the angles inside of this triangle with measures that are less than the measure of angle 1. Okay, well, -1. Okay. So, using this idea, I know that each of these non-adjacent interior angles has to be less than the measure of the exterior angle. Okay? I mean, it's kind of hard to tell that here. I mean, this is a small acute angle. These are both small acute. But using this theorem, we know for sure that angles 3 and 4 are both less than angle 1. Okay? So, if we look down at some of these exercises, okay, we're just doing that same thing with these triangles. Okay, so, for example, number 1 says, well, give me all the angles that we know for sure that are less than angle 1. Okay, well, I don't know for sure that angle 2 is. Okay, I can't just say, well, it looks a little bit less than angle 1. I can't do that, but I know for sure that angles 3 and 4 would have to be less than the measure of angle 1 because they are non-adjacent interior angles. Okay, so for this one, we could say 3 angle 4. I know for sure. Yeah, your greater than and less than signs could look like your angle signs if you're not careful. Right? Now, how about measures that are greater than angle 3?
2 and 5.
Well, how do we know that 2 is?
Oh, because because 1 is greater than 3.
All one, the other one. Rest.
I was thinking because 1 is greater than 2, so it has to be, and those are smaller, so 2 has to be greater.
Well, the way this triangle looks, I mean, it looks like these are both about 90, but we can't just assume that. I mean, this could be 160 degrees, right? Then if both of these are 80, this one would only be 20, so it's definitely not bigger than angle 2. Okay, so we can't just say, well, it looks like they're about 90. Okay, we can only look at the information we know for sure. What we know for sure is that 1 would have to be bigger than 3 and 4, and 5 would have to be bigger than 2 and 3. So we can say that the ones that we know for sure that are larger than angle 3 would just be 1 and 5. Questions? All right, let's take a couple of minutes. You guys try the rest of the front here. All right, take a look up here. Here are the answers.
Dude, I was right. Wait, isn't that good?
Why did I put 1?
Oh, dude, you shut up.
I ain't got that one right.
Right. Measure 3.
You know, like
I
7
was
on.
right, but it's kind of
7
I
on.
did. We did half a
You
step.
can make that. Actually, maybe 6. Let's try it.
I don't know if we need to look at all of them.
I've got like number
Oh, no, that's not all.
The only one I got right. Actually, no, I think 10. 4, 5, 7. Yeah. Part of the 9.
All right, which ones do we want to take a closer look at? 5. All right. So we're looking at measures that are less than angle 7. Okay. Well, first, I know angle 7 is exterior to this triangle. So I can say that angles 1 and 3 are for sure less than angle 7.
I don't understand. You're doing it. I see you like, oh, that makes complete sense. But then as soon as you have it makes sense, but then I'm just
Why is it 2 up there?
Don't look like an idiot. Why is it angle 2 up there?
It's less.
Well, it looks like it's less.
So it has to be less.
dude,
All we know for sure is that these two angles add to 180. That's all we know for sure.
just make that.
This could be 100 degrees. We don't know. We're not told any information about the actual measures. Okay, so all we know for sure is that these add to 180. Even though this definitely looks like an obtuse angle, we can't assume that it is. Right? So I know for sure angles 1 and 3 are less than angle 7. Well, now I can also say that angle 1 is an exterior angle to this triangle. So then we can say that angles 5 and 6 are less than angle 1, which means they would have to be also less than angle 7. Right? Then they also are saying that angle 7 is exterior to this whole triangle. Right? So angle 7 would also have to be greater than this entire angle, which is 3 and 5 put together, which they call angle, they just say it's angle TUV, and then angle 6 as well, but we already listed that one.
How will we know it's bigger than TUV?
Because angle 7 is exterior to this whole triangle. So angle 7 has to be greater than this angle and this angle. Okay? What other ones do we want to take a look at here?
6.
6?
That's the only one I got right.
So on number 6, we're looking at angle 2. Okay, well, guys, too much talking here. Angle 2 is inside of this triangle here. The only angle, non-adjacent exterior angle, is angle 4. Okay, angle 7 is adjacent to angle 2, so we can't use that one. So the only non-adjacent exterior angle to angle 2 would be angle 4. So I know for sure that angle 4 is greater than angles 2 and 3. Okay, that's the only one I can see for sure in this diagram that would be larger than angle 2. What else? 7. So angles larger than angle 5. This triangle here, angle 1 is our only non-adjacent exterior angle. So angle 1 would have to be larger than both 5 and 6. Then, angle 7, by the logic we used back in number 5, is exterior to this triangle. So angle 7 has to be greater than angle 1, which means angle 7 would also have to be greater than angle 5, because 1 is greater than 5. Then, we can also say, and this kind of isn't using the exterior angle, this one is just a little more common sense. If we're saying larger than angle 5, and then we add on a piece, so angle TUB is angle 5 plus some other angle, that would have to be larger than angle 5. And so that's where they get TUB for greater than angle 5. And what else? 7 is the one we just talked about.
Oh, I'm at 8.
So number 8, angles less than angle 4. Well, angle 4 is exterior to this triangle. So I know for sure that the two non-adjacent interior angles, which would be 2 and 3, are less than angle 4. And I think that's the only ones that we can see for sure that would be less than angle 4. That. So on this one, we want angles greater than 4 down here. Well, angle 4 is actually part of angle NPO here. So if I look at this triangle that's got angle 1 exterior, so I could say angle 1 is greater than this whole angle here, which means angle 1 would have to be greater than just a piece of that angle, which is angle 4. Same logic for angle 8. Right? Angle 8 would have to be larger than this whole angle, this whole angle. So angle 8 would have to be larger than just this angle. Right? Then, let's see. And then by the logic we used up here, angle 4 would have to be less than this entire angle because we're just taking angle 4 and adding a piece on. So angle 4 would have to be less than angle OPN. And then the last one, they say that this angle right here, angle ROQ, would be an exterior to this smaller triangle. So angle ROQ would have to be greater than both 4 and 6. Yeah, especially when we start throwing triangles inside of triangles, it can get a little bit tricky to catch all of them. Other questions on these? All right, then I think the back is a little bit more straightforward. Okay, so on the back, we just have a property that relates the angles and the sides of a triangle. Okay, it basically just says that the longest side has to be opposite the largest angle, and then the smallest side has to be opposite the smallest angle. Okay? So, here, if I know that AC, if I know that this side is longer than this side, so let's give them random measurements. Let's say this side is like 10 and this side is 7. So if I know for sure that AC is larger than AB, then that tells me that angle B has to be larger than angle C because angle B is opposite the longer side. Okay.
You're saying C has to be smaller?
C would have to be smaller than B. Yeah. I don't know for sure what the measurements are, but I know that since angle B is opposite a longer side than angle C, angle B would have to be larger than angle C. Think about a door. Okay? If I open a door this much, okay, I've got this little angle right here, and then I've got this much space between on this side of the door. The bigger I make that angle, the longer the opposite side is going to be. Okay, so if we're thinking about the different sides here, okay, the smaller angle has to be opposite the smaller side, and the larger angle has to be opposite the longer side. Okay, so yeah, if we just think about a door opening, okay, just make this the angle at which the door is opening. And the longer side has to be opposite the larger angle. So, all we're going to do down here is, like for example 1, I'm listing the angles in order from smallest to largest. So, my smallest side is SR. That means the smallest angle in this triangle is angle T. Okay, the angle opposite the smallest side. So if I'm listing from smallest to largest, I'm going to put angle T first. Then my next side, ST, is 7. So that means angle R would be next in this order. And then my longest side is RT. So angle S would be the largest. Cool. So then we can use the same logic if we're given the angles. Okay? The smallest side will be opposite the smallest angle. So my smallest angle is angle A. That means the shortest side is going to be CB. Then angle C is my next smallest angle. So AB will be the next longest side. And then angle B is the largest angle. Therefore, AC is the longest side. Okay. So the smallest angle is always opposite the smallest side. The largest angle is always opposite the largest side. Okay.